This is the last chapter in electricity. Good morning. This is the last chapter in electricity. We took DC voltage, AC voltage, voltage of the mains. We took also the resistors. We reach now chapter 9, which is electric power and energy. Page 109. You can see many electric appliances in your house. For example, these lamps, and you can see what's written on them. For example, this lamp, 2.5 volts, 3 volts, 220 volts. So what do these indications mean? These indications mean the rated voltage of an appliance to function normally. For example, for this lamp to function normally, you have to connect it to a dry cell of 3 volts. For this lamp to function normally, you have to connect it to the voltage of the mains in your houses, which is 220 volts. If you connect this lamp with a voltage less than 220 volts, it will not function normally, and its brightness will be less. Another term that you can see is 5 watts, 200 to 200 watts. Here, for example, 60 watts. What do these terms mean? These terms are the rated power of a lamp. It means the power it consumes to function normally. Also, this lamp 0.5 watt, it consumes 0.5 watt to function normally. The term power, it means the amount of work done by an appliance. For example, if this lamp consumes 200 watts and this lamp 0.5 watts, this lamp, its brightness would be more, of course, of this lamp. You can see here on the table rated powers of some appliances in your house. You have, for example, the quartz watch. It's the least one. It's the watch that you wear in your hands. Its watch, it's 0.001 watt, the power that it consumes. If you compare here the economic lamp that we use nowadays, the power it consumes is 20 watts, while the incandescent lamp that they used in the past, it consumes more power, which is 100 watts. You can observe as the power increases that the highest power here in the table is for the electric furnace. It consumes 3000 watts. So the rated power that you can see on any electric device is the power consumed by an appliance to function normally. The rated voltage is the voltage of normal functioning. Electric power is given as a symbol, the letter P. Its SI unit is watt W. It has also other units, the megawatt, kilowatt, watt, and milliwatts. To calculate power, you have to multiply the voltage with the current. The power equal U times I. U is used in volts and I in ampere. If in case of a resistor, the power lost by a resistor, you remember Ohm's law, it's U equal R times I, and I equal U over R. So to return to the formula P equal U times I, you can replace U by R times I. So we get P equal R times I square. Or you can replace I with U over R, and you get the formula P equal U square over R. If you want not to memorize so much, you can memorize the formula P equal U times I, and when you calculate, if you have in the exercise R, you can replace U by R times I, or you can memorize also these formulas for you to be easier. So if we have this lamp, we have the rated power, we have the rated voltage, we can calculate from them the rated current I equal P over U, and we get also the current needed for normal functioning, which is in this case 0.5 ampere.